Hello and welcome to the final presentation video for CIT 260. My name is Aimee Jorgensen and today I'll be sharing with you our Pioneer Trail Team project. I'll be demonstrating the Java skills we have learned so far while creating this game. Let's begin. The requirements for this class included designing and creating a simple Oregon Trail type game using Java object-oriented programming. We brainstormed some ideas, came up with the Mormon Pioneer Trail theme, and formed working groups. Together we developed a game that we're very proud to share with you. There are 7 objectives for this presentation. They are to explain the difference between static versus instance variables and how to reference and call them in functions, explain arrays, array lists, and enums and why we use them, show how to use basic statements and indexing to access array elements, how to catch runtime errors, explain the difference and use of character versus byte stream classes, and how to output and write files to an external source. Finally, to conclude, I will run through my team's Pioneer game with you. Let's begin. What is the difference between a static class variable and a non-static instance variable? Remember that a variable is a named memory location that can be assigned a value. A static variable is one that can be used independently without reference to an object, and no copies or instances of this variable will be made or stored in memory. Instead, they're shared. For example, in the following program to your left, you'll see Purchase New Supplies class. 2 different variables are created. In the first example, a normal instance variable x is created and it will represent the pounds of food. We will create multiple instances for x depending on the inventory items. The second variable is a static variable, integer, it's q. We write int q. We will use this variable to represent the quantity of food. If we were not planning on creating multiple instances of this variable, it would need to be static variable and it would be shared. The method product total will return the product of the static variable x and the instance variable q. In this example, we see the static function. We've created several objects of the inventory class. Each object, like food supply, med supply, tool supply, and weapon supply, have its own copy of an instance variable x, and pounds of food have been set for each object of the instance variable x. Within this same static class, each object will share one copy of a static variable. The static variable q is shared. The static variable q will be set to 1. Then several command lines are sent to print on the console. The object is first stated, followed by a dot, and the product total method. Remember, this is x times q, or pounds times quantity. For instance, the medical supply was assigned 20 pounds and the quantity is 1, so the printed statement would read, total medical supplies 20 pounds. Some things to remember. A static method can only call other static methods. It can be called from the class without having to create an instance of the class. To call or reference a static method, you will need to use the syntax class name, followed by a dot and a static method name. A non-static function will not have the word static before the name of the method. An instance of the class must be created somewhere. In this case, we created a new instance of the supply inventory class called food. The syntax for calling or referencing a non-static method is the object name, followed by a dot and the method name. Now let's learn about arrays versus an array list and an enum. An array is a collection of variables of the same type, referred to by a common name. They group together related variables and can be implemented as objects. You will first enter the type, followed by the array name, and the new type and the size. In this example, we use the type integer actor's age, and we specify that there will be 5 elements in the actor's age array by placing that inside the brackets. Actor's age is the array reference variable created and stored in the memory, and it is large enough to hold 5 elements of type int. Notice that the index will begin with the number 0 instead of a 1. In our program, we chose not to use a simple array, but the following slide will demonstrate this concept. In this example, the inventory control class will declare a new array reference variable name, nums, and assign it to hold 6 elements in memory. Using an index describes the position of an element within an array starting with 0. Next, to index each element, specify the number of the element surrounded by square brackets and assign it a value. This program finds the minimum and maximum values in the array. You should use an array list when you're not sure how big your list should be or if you need to add or subtract elements from your list. In our game, we added an array list for our inventory model. We wanted to allow the ability to add or delete inventory items from our list after each turn or obstacle. To do this, we used the following code. To create an array list in Java, you declare an array list variable and call the array list constructor to create an instance of the array list object and assign it to the variable. You can also assign it a limit, but it can increase and decrease as you add elements to the list. You can also specify what types of elements the list might contain. Our group decided to create an array list for our inventory supply, and we used that index to subtract or add inventory items during each scene of our game. Enums. An example of an enum list would be as follows and contains set elements that are constant and never change. We found this useful when setting the values for our actors, our scenes, and our inventory weight per item enum. In the estimate resource method, I was able to add an array list to the inventory model to add various food resources to the index. I then created a separate view to use as the general store, which would access those elements and combine the sum of all food purchased in the general store. Upon completion of my code, the food total weight would be added to the wagon's total weight. I'm still working out a few bugs in this process, but I get the general idea of how to utilize the array list to add an interesting addition to our view later. Now, we're always going to run into runtime errors, but there are ways to work around exceptions to your program when that happens. Let's discuss how to throw, propagate, and catch custom runtime errors in a program. An exception is an error that can happen during runtime. The exception handler will process the error so that the programmer doesn't have to do it manually. Errors can't always be resolved, but exceptions can be dealt with by setting up a class to handle them. There are 5 things to know about managing exceptions. They are try, catch, throw, throws, and finally. For this assignment, I used the try-catch method to catch any exceptions in my getFamilyReport string. One of my individual assignments was also to create a class for checking the weight of the food supply after a hunt. The weight needed to fall within the parameter set within my method and error checks. If an exception is caught within a try block, it is thrown. The code can catch the exception and handle it in a suitable way. Any code that must execute is put in a finally block. In Java, the preferred method for performing any reading and writing of data to the console is by stream classes. Input and output was primarily done with byte streams, and which are used for the input and output of binary data. Character streaming is more designed for the input and output of characters. With character streams, reader is used for input and writer for output. System.out is the standard byte output stream. In this class, we have also used print and println to send output to the console because they're fairly easy to use. Now that we learned about how to write some basic code for our simple Pioneer Trail game, it's time to learn how to write some of our character data for an external file. For one of my individual assignments, I created a program that would write a family report string to a file on my hard drive. This utility shared by our instructor illustrates how to output or write text to an external text file. First, you create the string method you'd like to execute. In this case, string getFamilyReportString was used to create a title for the heading. Mine was called Family Actors. Next, we had to create a display prompt where the user could key in a file path of where the report would be printed. The class name followed by open and close brackets, the variable, and call to run the getFamily method. Then another view layer was called to display the report. We used the syntax to specify a string format for a character string. This percentage character is used followed by a number to specify how large to make each column of text. A for statement must be used and the family report is returned. Next, another view layer function was necessary to print the report. It was a Boolean method called doAction, and it needed an if-try statement to take the input of P. This report used a character output stream, report.write, to write to the file, and a for statement to go through the list of items to be displayed. I printed a console print line success message if the report was printed to the right file path. At the very bottom, you can see a runtime exception thrown during the execution to catch any exceptions, and the error view .display function to display the error. If all was good after a test, I entered the file path of the file where the report I wanted it to print to. Then I exited the function and located and opened up the report file I wanted to print, or I did print. The first time running it, I got an invalid file path with an error message in the log file. So I did some corrections and it finally saved the report successfully to the file path. And now, without further ado, the Javanauts team of Cole, Derek, and Aimee's fully implemented Pioneer Trail game. So that concludes this